Hello friends, welcome to my YouTube channel Concept Clear. In today's class, we'll discuss about Encapsulating Security Payload (ESP) in the subject of Cryptography Network Security. Okay, here ESP it is the one of the major part in IP security architecture. Here, in order to achieve the confidentiality, we use some cryptography algorithms. Okay, here ESP it provides confidential services including confidentiality of the message contents and limited traffic flow confidentiality. Okay, here majorly it provides the confidentiality. To achieve the confidentiality, we have to use cryptography algorithms. Okay, next here which type of algorithms we'll use means we'll use DES algorithm, 3DES algorithm, RSA algorithms like this. These are type of algorithms we can use for to getting the confidentiality. Okay, here ESP can also provide authentication. Okay, here what is the encapsulation header file? Header is the header. It contains the totally 32 bits, 32 bytes, 0 to 31 bytes. Okay, in first one it will have security parameter index. Second one is the sequence number. Some textbooks they given as the service number. Okay, here it is the sequence number. Next one is payload. It is a variable. And next one is padding. It contains 0 to 255 bits and pad length, next header and authentication data. It is the optional part. Okay, here we will discuss one by one. What is the security parameter index? Security parameter index is nothing but it identifies a security association. Whatever the associations are involved, okay, those associations will be identified the SPI. What is the meaning of association? Association is nothing but what? It is the communication between client and server. It is the communication between client and server. Okay, next one is the sequence number. Okay, it is also contains the sequence number also contains the 32 bits. Sorry, it is also 32 bits. Here the sequence number it is nothing but it is a monotonically increasing counter value. It is just a number. It will for every packet contains the one sequence number. It follows the sequence number and it is a monotonically increasing the counter value. First packet is delivered. Next one is what? Packet 1, packet 2. So packet 1, 2, 3 and so on. So it is the increase the value size and it provides the anti-replay function. Okay, it is also provides the an anti-replay function. The next one is payload data. What is payload data? Payload data is nothing but it is a transport level segment or internet protocol packet internal that is the protected by the encryption. Okay, here it is a payload data that will be protected with encryption. That is protected with encryption. Next one is the padding. What is the meaning of padding? We know what is the padding means. Adding additional bits. Adding additional bits end of the data to confuse the hackers. That is called padding. Okay, pad length. What is the meaning of pad length? It indicates number of pad bytes immediately preceding. Okay, how many bits we are adding to the original data. That is called pad length. Okay, generally it is the 8 bits. Next header is also 8 bits. It indicates the type of data contained in the payload data field by identifying the first header data payload. Okay, this is the next header. Next one is the authentication data. Authentication data is nothing but it is a variable length contains the integrity check value. Okay, it will check the integrity. Okay, the data is modified or not. That is the integrity will be checked by the authentication data. Okay, here the header format in IPv4 and IPv6 implemented in two transport mode and as well as the tunnel mode. Okay, here IPv4 in transport mode. First, what is the format here? Original header, TCP part and data part. This is the IPv4. And what about IPv6? It contains the original header, extension header, TCP data. This is the general implementing in two modes. Okay, before above are the packets formats before implementing the encapsulation is the encapsulation before implementation, and after implementation of ESP, what is the transport mode? In the transport mode, the data will be like this. IPv4 is original IP header, is the original header, and ESP header and TCP data, and again here ESP header and ESP authentication, these two will be added. Okay, these two will be added here. Data will be encrypted. Okay, how to identify the data encrypted means this dotted highlighted, these three are the encrypted, these three are the encrypted format. And what about IPv6? In IPv6 is also original IP header, extension header, ESP header, and these are the encrypted data, and last one is the ESP authentication. Okay, this is the in ESP applying after applying in transport mode. This is the without applying transport mode. This is the applying transport mode, and after applying in ESP in tunnel mode. Okay, in tunnel mode also same. Here NP new IP header, ESP header, and original IP header, TCP data, ESP header, ESP authentication. Here it is also, these are the fields is encrypted. These are the data is encrypted. Okay, after applying IPv4 in tunnel mode, IPv6 in tunnel mode, again same diagram. Okay, here ESP and encapsulating security payload and authentication header, both are protocols implemented for achieving IP security. Here ESP for achieving the confidentiality, and a authentication header for achieving authentication along with integrity. Okay, clear? Here what is the first one? ESP for achieving confidentiality, and authentication header achieving authentication and integrity. Okay, clear? This is about the encapsulation security payload. Okay, if you have any doubts, please ask me in the comment section, and like our video and subscribe our videos. Thank you everyone.
నా ఛానల్ పేరు గుర్తుందిగా, ప్లీజ్ లైక్, షేర్ అండ్ సబ్స్క్రైబ్.